Okay, so good day, guys. So what we're going to talk about today is the SSS and SAS congruence postulate. So our session objectives for today are as follows. So the first one is define and discuss SSS and SAS congruence postulates, and then give additional information needed in order to prove that the triangles are congruent by SSS and SAS congruence postulates. And then later, we are going to use two-column proofs to prove that the two given triangles are congruent by SSS or SAS congruence postulates. Now, before we proceed with that, let us first recall the different triangle congruence postulates or theorems. Okay, so the first one is our SSS or the side, side, side. Alright, the second is our side angle side or the SAS, and the third one is the angle side angle or the ASA. Okay, and then the fourth one is the angle angle side or AAS. So the first three are all postulates, while the AAS is a theorem. Right. So but before we proceed, let's first have some properties of congruence. What are these? So these are the reflexive property of congruence, then the symmetric property of congruence, and then the transitive property of congruence. Now, how do we illustrate all of this? So suppose I have the sides line segment AB and line segment BC and line segment CD. So, illustrating this by reflexive property of congruence, so we can just simply say that because it is reflexive, it is a reflection of its own. So therefore, if it is a reflection of its own, it is congruent to itself. So AB, line segment AB is congruent to line segment AB, or we can also represent this as BC is congruent to line segment BC and CD is congruent to line segment CD. Alright. Now, how about symmetric property of congruence? So, this means that if you interchange the position of the letters, it will just be the same. So, say for example, line segment AB is just congruent to line segment BA. Yeah, switching the position. So, BC, line segment BC is congruent to CB, or CD, line segment CD is congruent to line segment DC. Right. Now, how about the transitive property? So, the transitive property illustrates that if line segment AB is congruent to line segment BC and line segment BC is congruent to line segment CD, so we can say that line segment AB is just congruent to line segment CD by transitive property. So, we say that line segment AB is congruent to line segment CD because AB there is congruent to BC and BC is congruent to CD. Therefore, they will just be congruent to each other. So, AB is just congruent to CD by transitive property. So, we need to remember all of these properties of congruence because when we try to prove triangle congruence, we need this. Okay? We need this to bear in mind. So, how do we illustrate the first, the SSS congruence postulate? So, in this figure, it's very easy to identify because the two triangles are congruent to each other and they are marked by tick marks. So, illustrating that the sides are congruent. So, if you look at the pairing, so they are paired together and then they are congruent by SSS congruence postulate. Alright. And also, this example. So, we are all guided by the tick marks illustrating that the three sides are congruent. Okay, now, what is SSS or side, side, side congruence postulate? So, by definition, SSS side, side, side congruence postulate, if the three sides of one triangle are congruent to the three sides of another triangle, then the triangles are congruent. So, if you can see these two triangles, now, if they are congruent by SSS, so we can illustrate that although these have different orientation, but we can say that by pairing the corresponding sides, so we can say that they are congruent. So let's just have them by pair. So this one, that side is paired with this one, and this side is paired with this side also, and then the last, so 3 tick marks there, there it goes. Okay, so for me to be guided, so let's see. So following the SSS, we have the tick marks as our guide. So in this case, the first side, if I'm going to get side ED, alright, so that would be congruent to side AG. Alright, and then if we have the next side as DI, okay, so that would be congruent to, so GW. Alright, next. So the last one is side EI is congruent to side AW. Alright, and you just name the two triangles that are congruent. So in this case, triangle EDI is congruent to triangle AGW by SSS congruence postulate. Right, so that's how we illustrate two triangles that are congruent by SSS, the side, 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 congruence postulate. Okay, so next, the next thing to do is to develop your own skill in identifying the additional information that is needed to prove that the two triangles are congruent. So in this case, we have this triangle, so triangle number 1 and then triangle number 2, and we can say that these two triangles are congruent. Now, for us to determine that really the two triangles are congruent, we need to name the additional side. So in this case, we are referring to the additional information that is needed, alright, to complete the SSS. Now, if you can see, we already have this side of the triangle that is congruent to this side. And then also, this side is congruent to this side. So we have S. Okay, so referring to this first triangle, we have the two sides already. So similarly, we also have the two sides here. Now, for us to complete the SSS, which side are we going to get that we are sure, okay, that that side is congruent to the other side? So in this case, I can see that side BD, okay, is congruent to side BD. Okay, so this is that side. Okay, so BD. Now, why are they congruent to each other? Because we know that they illustrate reflexive property of congruence. There it goes. So that is the additional information needed to complete the SSS, congruence postulate. Okay, so then next. Now, in this case, look at this. What additional information is needed in order to prove that the triangles below are congruent by SSS congruence postulate? Now, if you look at these two triangles, so we have, say for example, this is triangle 1 and this is triangle 2, and we also have all of these marked, okay, marked side which are already congruent. So we can say that we already have two sides that are congruent. So just name the additional side that will complete, okay, the SSS congruence postulate. So in this case, we are going to get the remaining side. So this one and this one. Now take note of the orientation. So if I say I'm going to get AD, so side AD, that would be congruent to side side CB. Alright, so yeah, so that's the remaining side, AD and then CB. Okay, so it is now complete. So S, S, and S. Okay, so that's it. Next, let's proceed with the SAS, or the side angle side congruence postulate. Now, this side angle side congruence postulate tells us that if the two sides and an included angle of one triangle are congruent to the corresponding two sides and the included angle of another triangle, then the triangles are congruent. Now take note that we have two sides and an included angle. So we say that if it is an included angle, it is located between the two sides. Okay, it is found between the two sides of the triangle. Okay, so meaning to say it should be enclosed. Okay, it's not located outside, inside the two sides. Okay, so let's see. If we have these two triangles, okay, how are we going to illustrate the SAS congruence postulate? So if I'm going to get this side and pair to this side, okay, so if side MA is congruent to side TI, okay, that's your side. Now, we need to get an included angle. So, if I get angle A, so let's see, that's angle A is congruent to angle I, okay, so the next side must enclose, okay, angle A and angle I so that they become between the two sides. So I'm going to get this side, okay, and that side. So side AR is congruent to side IN. Okay, so look at the position of the angle. So the angle is actually between the two sides. Okay, so any other combinations will do for as long as you need to remember that the angle must be between the two sides. So then we can say that we can name the two triangles. So triangle MAR is congruent to triangle TIN by, of course, side angle side. Congruence postulate. Alright, so that's how we illustrate the SAS congruence postulate. Now, there are figures which instantly show us the SAS. So, in this particular example, so it's obvious that this one is already the SAS. So, side, an included angle here, and then another side. So, remember, it must be included angle for us to illustrate properly the SAS. Okay, and also the pairing here. Okay, now, let's try to determine in which pair of triangles pictured below could you use the side angle side postulate or the SAS to prove that the triangles are congruent. So, which of these pairs illustrate to us the side angle side congruence postulate? Now, let's first try to observe pair number 1. So in this case, this is side, and this is angle, but the angle is not included. Alright, so meaning to say, this does not illustrate, pair number 1 does not illustrate the SAS. Okay, so next, pair number 2, let's see. Oh, so this is the side, and this is the angle. So the angle is outside of the two sides. So these do not illustrate to us. Pair number 2 do not illustrate to us, or does not illustrate, I mean, to us, the SAS congruence postulate. Okay, so pair number 1 is not, pair number 2 not, pair number 3, let's see. So side, oh, so the angle is not included, so not. Okay, so next. So pair number 4, oh, this is the side, this is another side, and the angle is in between. Alright, very good. So, pair number 4 illustrates the side angle side postulate, or the SAS. Alright, so we only have here the pair number 4. Okay, so, now, similarly, we can also express the congruence of these triangles, but 3 ways. So there are 3 ways in which we can illustrate, because there are 3 combinations. Okay, so let's see. This one is paired with this one, this side, and then the last one. Okay, so let's just draw the tick marks and the angle marks there. So I is paired with this, with C, and then this one, 2 angle marks, And then the last one, 3 angle marks. Okay, and then we're ready to get the pairing. So there are 3 possible combinations. So by SAS. So let's begin with the first. So if I get IO that is congruent to CA, okay, I'm going to get, say for example, angle O congruent to angle A, and then it should be included. So I'm going to get ON, side ON, congruent to side AT. Alright, so that is our first way. Okay, combinations. Next, so if I am going to get side ON, okay, congruent to side AT, okay, so I'm going to get angle N is congruent to angle T. Now, take note, please be guided by the angle marks and the tick marks for you to pair them correctly, the corresponding angles and then the corresponding sides. So, again, it should be included. So, angle N and angle T must be included. So, I'm going to get side IN is congruent to side CT. Okay, so this is our second way. Next, the last is, so if I get IN, okay, that's congruent to CT, and then angle I is congruent to angle C, and then it should be included. So IO, side IO is congruent to side CA. So this is the third way. Alright, so that's how we illustrate the SAS congruence postulate. And we can name the 2 triangles that are congruent. So triangle ION, okay, is congruent to triangle CAT. Alright, so that's how we illustrate the SAS congruence postulate. Okay, so again, we are going to get the additional information needed for us to prove that the 2 triangles are congruent by the SAS postulate. So in this case, because we have already the side, okay, so again, paired with this, and then we also have the angle, okay, paired with this also, the angle must be included, okay, so must be between the 2 sides. So what we're going to get are these sides. Alright, so for the angles to be included. So that would be, the additional information would be side LG is congruent to side MN. Alright, so this is our additional information. So it's already complete. So we have the side, we have the included angle, and also the side. So similar with this, side, angle, and then side. Okay, so in other cases, we also need to give the additional information, not just one, okay, but 2, depending on the clue that the figures would give to us, would provide to us. So, in this example, let's look at this. What additional information do you need to prove that the triangles are congruent by the SAS postulate? Now, look at this, okay, so only the angles, okay, are provided to us as the clue. Now, we're going to supply 2 informations. Okay, so the first one is, we know that this one is already congruent, right? So, that's side PR. So, PR is congruent to side PR by reflexive property. Okay, so that is already side. Now, take note that in SAS, the angle must be between. Alright, so I am not going to get this side, the QP and then the SP, because that will not include the angle. So I'm going to get this side. Okay, so that would be QR is congruent to SR. Alright, so SAS. So we're now complete. So that's SAS. Alright, so that's how we determine the additional information that is needed. Now let's try. So given, so we have these two triangles. Given, point C is the midpoint of BF. So point C is the midpoint. Now take note, because it is a midpoint, okay, it divides the line segment into 2 congruent parts. Now AC, So this one is given already. AC is congruent to CE. Now, the question is, from the information given, can you prove that triangle ABC is congruent to triangle EFC? And then explain. Now, we just need to decide if the two triangles are indeed congruent based on the clues that are provided to us. So, meaning to say, does it follow the particular congruence postulate? Okay, so if I'm going to get SSS, okay, so let's see. I know that this will become congruent to this one. Alright, now, why is it so? Because I know that this C is the midpoint. So, therefore, it will divide the entire line segment into two congruent parts. So, I am already sure with that. Okay, so, but, what else do I need to get? Okay, so that I can prove that these two triangles are congruent. I can see angles that are congruent. Okay, so therefore, I can say that this angle is congruent to this angle. Why? Because they are called vertical angles. Alright, so they are called vertical angles. So, I have completed. So, this is S, A, and this is S. So, SAS congruence postulate. Okay, so the SAS congruence postulate is already enough to prove or to say that these two triangles are already congruent. Alright, so that's it. Next. So, let's see. Given. So, RE is congruent to CA. Alright, there it is. Then RD is congruent to CT. And then angle R is congruent to angle T. But take note, let's look at this. Side, angle, and then side. The angle is included between the two sides. But here in the second triangle, look at that. So, side, and this is the angle. So, the angle is not included between the two sides. Now, from the given information, can you prove that triangle RED is congruent to triangle CAT? So, obviously, we can say that they are not congruent because of the different positions of the angles. Alright, so they illustrate differently than the usual SAS because the angle must be between the two sides. Alright, so next. So the next thing to do is to use the two-column proof in proving that the two triangles are congruent by either the SSS or the SAS congruence postulates. Now, what we're concerned here are the following. So, the first is, what is a two-column proof? And then, how do we use the two-column proof to prove triangle congruence by SSS or SAS congruence? Okay, so, let's first be familiarized with the two-column proof. Now, this is a particular way to illustrate triangle congruence by proving and using two-column. Okay? Two-column proof. Okay, so let's be familiarized first. So, we are always provided with the given portion. So, this is the given portion. Okay, now the given portion would tell us the clue. Okay, so if we're going to go to the figure, this given, okay, so in this case, line segment RP is congruent to line segment RT. So, we also have here the figure, okay, illustrating our given. So, this facilitates to us, or this gives us the clue as to what particular statements and then reasons are we going to write in the two-column proof, and then following the congruence postulate, either in this case of our discussion, the SSS or the SAS. So, we also have the proof statement. So, when you say the proof statement, this is the thing that we're going to prove. So, prove the triangle PRX is congruent to triangle TRX. So, that's it. So, that's the thing that we're going to prove. And then, because it is called two-column proof, okay, we have a table here, and then we have two columns. One column, okay, is the statement, and then the other is the reason. Okay, so the statements are the congruent sides or angles, okay, that can be illustrated in the figure and will give us a clue, okay, as to what particular type of the congruence postulate are we going to use. Okay, now, for every statement, there is always a corresponding reason. Okay, and these reasons are what we have learned so far in geometry. Okay, so we are going to discuss further the particular reasons that we can use in the two-column proof. Right, so be familiar with this two-column proof. Okay, so these are just some important reasons that we can use. So if we have a statement, and then if we're looking for a particular reason for that statement, you can use all of this. Okay, so the first one is the definition of a midpoint. Okay, definition of perpendicularity, or definition of right angles, or all right angles are congruent. And then the vertical angles theorem, definition of angle bisector, the Paella theorem, or if parallel lines are cut by a transversal, then alternate interior angles are congruent. And we also have the definition of line or segment bisector. Now, we're going to discuss this one by one. Okay, now, definition of midpoint. So, the midpoint, if we have a line segment, so the midpoint is located in between. So, if this line segment is line segment AB, and then I designate this midpoint as C, of course, we know that this divides, okay, so the midpoint, okay, indicates that the line segment is divided into two congruent parts. So, this side is equal to or congruent to that side. So, we say AC, line segment AC is congruent to line segment BC. Okay, so that is the role of the midpoint there. Okay, so definition of midpoint. So what you're just going to write under the reasons in the two-column proof is simply, you can just write like that, definition of midpoint. Okay, so the shorter, the better. Okay, no need to further elaborate. Okay, or write in words. Okay, it is already understood. So next, definition of perpendicularity. So these are all the same. So when you say perpendicularity, right triangle and all right angles, and all right angles are congruent. They just mean the same. So how do we illustrate perpendicularity? So the symbol for perpendicular is like this. Okay, so if you have this symbol, meaning to say, if you illustrate, okay, if I draw a triangle, okay, so triangle ABC, and then I drop a line, okay, line segment there, okay, and then I name this BD. So I can say that if BD, okay, is perpendicular to AC, okay, this means to say that because it is perpendicular, I can form a right angle there. Alright, so meaning to say, because I have right angles there, okay, one triangle has a right angle and another triangle has also a right angle. So I can say that angle BDA is just congruent to angle BDC. So what is the reason for that? Simply because you're just going to say definition of perpendicularity. Okay, so we know for a fact that, or if you want one letter, that is just okay. So angle D is congruent to angle D. So what does it mean? So you can also say that definition of right angles. Okay, or right angle. So because we know that right angles are all congruent because they measure 90 degrees. Okay, or if you don't want to use these two, you can just say all right angles are congruent, but you're writing too much words. Okay, the shorter the better, and it is already acceptable. Okay, so next, vertical angles theorem. We know for a fact that vertical angles are always congruent. So if we have this angle 1, angle 2, we say that angle 1 is congruent to angle 2 because they are vertical angles. So simply, we can just write under the proof VAT or VAT. So vertical angles theorem. Alright? So, say for example, this is also another, okay, 3 and 4. So angle 3 is congruent to angle 4 by vertical angles theorem or by the VAT. Next, so definition of angle bisector. So what is an angle bisector? So if we have an angle, say for example, that is our angle, so A, B, and then this is C. An angle bisector is a line segment, a line, or a ray that divides an entire angle into two congruent parts. So say for example, I am going to draw there, okay? So let's say this is D, okay? So and this is a ray, okay? So ray BD, okay, bisects, okay? So by saying bisects, and this is an angle, so it's understood that this is an angle bisector. So BD, okay, ray BD bisects, so angle ABC. So what can we conclude? So we can easily conclude that angle ABD, okay, this is it, is congruent to angle this one. So DBC. So what is our reason? Our reason is simply definition of angle bisector. Alright, so that, or if you want to use only one letter, that's okay. So angle B is congruent to angle B. So still the reason is definition of angle bisector. So again, an angle bisector bisects or divides an entire angle into two congruent angles. Okay, so next. Now, what is the Paella theorem? Paella is just an acronym, okay, for the if parallel, so that's P, if parallel lines are cut by a transversal, alternate A, so alternate interior I, angles are congruent. So, simply, Paella theorem. Now, you learned already that when lines are cut by a transversal, so we can say that alternate interior angles are congruent. So if this is angle 1, this is angle 2, they are alternate. So we say that angle 1 is congruent to angle 2. They are alternate interior. Okay, they are alternate and located inside. Okay, so in writing the reason, you can just say Paella theorem. Okay, as simple as that will do. Okay, so let's illustrate. So if this is angle 3, this is angle 4, we say also that angle 3 is congruent to angle 4 because of the same reason. They are alternate interior angles. Okay, so that's the Paella theorem. Okay, another one is the definition of line or the segment bisector. So just the same concept with the angle bisector. An angle, if you have an angle bisector, an entire angle is divided into two congruent angles or congruent parts. Now, if we have a line bisector, because you can draw line. So, segment bisector, segment. So, say for example, if this is the line segment, so that's AB. And then also, I have another line segment. So, this is, say for example, CD. Now, so we say that CD, okay, bisects, okay, AB. Alright, so, bisect. So, because we are given two line segments, meaning to say, this is segment bisector. Okay, now, what does the segment bisector do? It divides also the segment into two congruent parts. So, this one will be congruent to this one, if this is the point. Okay, so, CD bisects AB at, let's see, at point, let's see, E. Okay, at point E. Okay, so, we say that side AE is congruent to side BE. So, what is our reason? Our reason simply is definition of segment bisector. Alright. Now, if this is a line, then you just say line. Okay, line bisector. Okay, but in our previous example, so that is a line segment. Okay, so those are the reasons that we need to understand, okay, and use as we write the two-column proof. Okay, now let's now write two-column proofs. Okay, so the first thing to do, again, you are provided already with the given and then the proof statement and then the figure. Okay, now what we're going to do is to make our table. So the first one is this one. So statement, throw the table, and then the reason. Okay, now how do we do this? The very first thing to do is to write all the given. Okay, so number 1, so HI, line segment HI is congruent to line segment JK. What is the reason? Given. Okay, because it is already given to us. So the reason is given. Next, number 2, just write everything. So line segment IJ is congruent to line segment KH. What is our reason? Still given because that is already given. Now, we're done with the given. Okay, so you designate this given, okay, as, is it a side or is it an angle? So we look at this. This is already a side and this is a side. Now, after doing this, you look at the illustration and try to locate. Now, we are guided already by the illustration because of the tick marks. Now, if there are no tick marks in the illustration, then you put or write the tick mark. So, HI, so this is it. HI is congruent to JK, that's it. And IJ, okay, is congruent to KH. There it goes. Now, I am going to look for, okay, a particular side or angle that will complete the congruence postulate. But make it sure that you have a reason for saying that that angle or side is congruent. Okay, following a particular congruence postulate. Now, if I am going to use the side angle side, okay, and say for example, I'm going to get this angle, angle I and angle K, because they are between the two sides. But come to think of it, do I have a reason for saying that angle I is congruent to angle K? I don't have any reason, right? I cannot think, okay? But if I am going to look at a particular side, in this case, this side, ask again yourself, do you have a reason for saying that these sides are congruent? I have a reason. Therefore, I can say that they are congruent. So, I am going to write them. So, JI is congruent to line segment JI. So, this is it. Okay, 3 tick marks. So, this is still a side. Okay, so what is the reason? So, the reason is for saying that JH is congruent to JH is reflexive property. That's it. Okay, reflexive property of congruence. Okay, or simply reflexive property. Now, we are already complete. SSS. Okay, so what we're going to write, because the congruence postulate is already completed, okay, with the 3 sides that are congruent, we can now write the proof statement. So, just write the proof statement. Triangle HIJ is congruent to triangle JKH. Now, what will be our reason? The reason is this one, SSS, okay, congruence postulate. Okay, so let's review again. How do we do this? You write, you make a table, okay, statement, and then reason. And then the first thing to do is to write all of the given. Okay, because they are given, of course, the reason is given. And then, you determine if it is side or angle. So, in this case, sides. And then you go to the figure. Okay, so that you would be given a clue. Okay, so, then, complete the congruence postulate. Think about, if you're getting an angle, think about, do you have a reason for getting the angles that are congruent or the side? So, in this case, we got the sides because we are sure by reflexive property that they are congruent. So, after completing the congruence postulate, you need to write the proof statement. Alright? So, that is how we do the 2-column proof. Now, let's proceed with more examples. Okay, example number 2, this one. Given, okay, side JK is congruent to side NK, A is the midpoint of JN. So this is the proof statement. Prove that triangle JAK is congruent to triangle NAK. So again, we first write, okay, so the statement, okay, draw the table, and then the reasons. Okay, so number 1, again, first step, write all of the given. So JK is congruent to NK. So what is our reason? Given. Okay, next, number 2. So A is the midpoint, okay, of JN. Okay, so given again. Now, doing this, so you are sure already that this is a side, of course. Now, go to the figure. Okay, so it's already marked. Okay, so JK is congruent to NK. Now, look at this. A is the midpoint, okay, of JN. Because it is a midpoint, we are already given the clue. So, therefore, we can say that, so, this is the midpoint. So, this part is congruent to this part. So, therefore, side JA is congruent to side NA. Okay? So, this is side also. Now, I can see, okay, I can see another side that is congruent. Okay? Now, this side is already congruent by reflexive property. Okay? So, I am going to get that. So, that side AK is congruent to side AK. Okay? So, what is the reason? Wait. So, number 3, the reason here is definition of midpoint. Alright. So, number 4, this is also the side. So, the reason is reflexive property. Okay. So, we're complete. So, SSS. Now, why did I not get the angles? Okay? Because the given did not tell us that AK is perpendicular. Okay? So, do not assume that they are right angles. Okay? So, we are already sure that we're complete. So, SSS, congruence postulate. So, therefore, I am now ready to write the proving statement. So, number 5, triangle JAK is congruent to triangle NAK. So, our reason here is SSS, congruence postulate. Okay, and we're done with the 2-column proof. Okay, so more examples again. Example number 3. So, let's look at this. So, let's first construct the table. Okay, so statement and then reason. Alright, so again, the first step is write the given. So, AM is congruent to BN. So, our reason is given. Okay, next, number 2. So, BM is congruent to AN. So, our reason is also given. Okay, so, let's look at this. So, the figure is not marked. Okay, so, we're going to mark. So, this is side, this is also a side. So, AM is congruent to BN, and then BM, so this one. So, BM is congruent to AN. Alright, now, so in this case, I can see a third side that is congruent and I have a reason. Okay? I am not going to get any angle because what we're proving is angle M is congruent to angle N. So, I cannot use the SAS. Okay? Because this is what we're proving. Angle M is congruent to angle N. But I have a side that is congruent. So, AB. So, AB is congruent to AB is congruent to BA. Or AB. So, AB is congruent to AB. Okay? So, reason is reflexive property. Okay. So, I'm now already complete. Now, because we have completed already the SSS, it always follows that you name the two triangles that are congruent. So, number 4, okay, again, this is a must. If you have already completed the congruence postulate, you always name the two triangles. Okay? So, the triangles are, okay, triangle AMB, alright, is congruent to triangle. So that's B and A. Okay, so B and A. So therefore, our reason here is SSS. Okay, congruence postulate. Okay, now, the proof statement is this one. Okay, now, prove that angle M is congruent to angle N. So, because we're already complete, and we have proven that the triangles are congruent, we can say that, number 5, angle M is congruent to angle N. Now, following, okay, the rule that the two triangles are already congruent, we can say that all of the angles, all of the sides are also congruent. Okay, corresponding sides and corresponding angles are also congruent. So, therefore, the reason is CPCTC. So, what does CPCTC mean? So, corresponding parts of congruent triangles are congruent. So, simply CPCTC. Okay, so this is another form. Now, compared to the previous. So, in our previous examples, so it ended with this one, the proof statement, the triangles. But in this case, the ending is this. So, the angles. Okay, so just a variation. Now, take note of how it ended. Okay, so it is a must that if you completed already the congruence postulate, write the name of the triangle. Okay, the names of the triangles that are congruent. And then, the proof statement. Then the reason is CPCTC. Okay, let's have another example for that. Okay, now, let's look at this. Let's see. So, prove that angle G is congruent to angle I. Okay, so let's just write or make the two-column proof. So, statement and then the reason. Okay, so again, write the given. Number 1, so JG is congruent to HI. So, reason is given. Okay, next. Number 2, so K is the midpoint. Alright, so we're already given a clue. So, K is the midpoint of GI and JH. Okay, so reason is still given. Okay, next. Let's go to the figure. So, JG is S. Okay, JG is S. So, K is the midpoint. So, if K is the midpoint of JI and JH, therefore, it divides. Okay, so if it divides, let's look at this. So, we know that this one is congruent to this one, right? Okay, so, number 3, so, GK, okay, is congruent to IK. So, reason is definition of midpoint. Alright. Now, we can also have this one. Okay, there. Okay, so number 4, so this is again side and this is again side. So, JK is congruent to HK. So, our reason here is, again, definition of midpoint. Now, are we already complete with the congruence postulate? Yes, SSS. So, we name the two triangles that are congruent. So, therefore, triangle JGK is congruent to triangle HIK. So, our reason is SSS congruence postulate. And the last thing that we're going to do is to write the proof statement. So, angle G is congruent to angle I. Then, our reason is CPCTC. Corresponding parts of congruent triangles are congruent. Alright? So, this is another example of a two-column proof. Okay, so next. Okay, example number 5. Okay, so this one. Okay, so, given, okay, so, GQ is congruent to TV and then it bisect each other at R. So, let's again write the two-column proof. Okay. I hope that we will be getting a different congruence postulate here. not anymore SSS. Okay, let's just see. Okay, so right. Number 1, GQ is congruent to TV and bisects. Okay, bisect each other at R. So, the reason is given. Alright, so we are given already a clue. So, let's see, GQ, so this is GQ, and then TV, bisect. So, meaning to say, both of them are segment bisectors. Okay, so, therefore, we can say that this is congruent to this, right? Okay, so number 2, so GR is congruent to QR. Now, the reason is, I am going to write definition of segment bisector. Okay. Because it's understood from the given that it bisects. It did not say a midpoint. Okay? So, you're going to use segment bisector as the reason. So, next, number 3. Now, this is side, right? But, okay, I can see an angle that are congruent, angles that are congruent. Okay, so here, angle R is congruent to angle R, right? So, angle R is congruent to angle R. So, what is our reason? So, looking at the angles, they are vertical angles. So, the reason is simply vertical angles theorem. Okay? And then, next, number 4. Oh, I can see, again, bisect. So, this side is congruent to this side. Okay? So, S. So, TR, side TR is congruent to side VR. Okay, so the reason is, number 4, again, definition of segment bisector. Okay, so we already completed the congruence postulate, so we are now ready to name the triangles. Okay, so our proof statement ends with the triangle. So triangle TGR is congruent to triangle VQR. So our reason here is SAS congruence postulate. And that's it. So that ends our 2-column proof for this example. Okay, so very good because we have our example for SAS. Okay, so let's proceed to the next. Okay, so in this case, we have line PC is perpendicular to AB at its midpoint C. Okay, so we are given with 2 clues there, perpendicular and midpoint. So let's again first write our statement, construct our 2-column proof. So, reason. Okay, so number 1, again, write the given. So, line PC, okay, is perpendicular to AB at its midpoint C. Okay? So, reason is given. Okay, number 2. So, based from the clue, we need to go to the figure and, okay, mark the triangles according to the clue. So, therefore, if PC is perpendicular, we know that we have 2 right triangles that are congruent. Okay, at its midpoint C. So, if this is the midpoint, also, we are sure that these are congruent. Okay. Now, next is, I can see sides that are congruent. Okay, so this one, they are congruent. So, it follows the SAS. Okay, so, let's see, let's write. So, PC is congruent to PC, okay, by reflexive property. Okay. Reflexive property. Next, number 3. So, I know that angle, so I will just use one letter. So, angle C is congruent to angle C. So, our reason is, that's it. So, definition of perpendicularity. Or if you want to write definition of right angles, that is also correct. So, if you also write, all right triangles are equal or congruent, that's also correct. Okay, next, number 4. So this is already S. This is A. So the last is, because we have a midpoint C, therefore AC is congruent to BC. So that is our side. So number 4, our reason is definition of midpoint. All right. Okay, so the congruence postulate is already complete. Okay, SAS. Now, name the two triangles that are congruent. So, triangle APC is congruent to triangle BPC. Okay, so reason, SAS congruence postulate. Now, the proof statement is that one. Okay, number 6. So, PA is congruent to PB. So, our reason here is CPC TC. Okay, corresponding parts of congruent triangles are congruent. So, that's it. So, this is the two-column proof for this example. Okay, so that's it, guys. So, thank you very much for listening. So, this is how we do the two-column proof for SSS and SAS congruence postulates.